Okay, Pythagoras' theorem. You've probably heard the words. You might have seen it before, but let's get into it. Now, we don't always realize how useful Pythagoras' theorem is. I realized this one particular use of it last year when my year 7s had to design a zoo, and they made all these amazing enclosures, all sorts of shapes for the different animals, but they realized at some point that even though they could find the length of straight lines like that, they couldn't find the length of diagonal lines like this. So the straight line, it's just because the scale here says 1 centimeter is 4 meters. That means I've got 4 meters, another 4, another 4. I've got 12 meters here. But they didn't know how to find these diagonal lengths, and that's what we're going to use Pythagoras for. So here's a diagonal length, and here is 2 straight lengths that can help you work it out. So here, this one is just 3 blocks, which means just like the other one, it must be 12 meters. And this one was 2 blocks, so that means it's really 2 times 4, which is 8 meters. And I can use Pythagoras' theorem to find the third side, and we'll call that C. Also, by the way, there's a right-angled triangle. Pythagoras only works for right-angled triangles, and this longest side, called C, is also called the hypotenuse. That comes up sometimes. Okay, so the equation to solve this is C squared equals A squared plus B squared. And A and B are just these two here. It doesn't matter which one is which, because they're just added together. So 12 squared plus 8 squared is the same as 8 squared plus 12 squared. So it doesn't matter which order, which one's A, which one's B. But the longest side is always C. Alright, so let's substitute some numbers in. We want to find this diagonal length, C. So let's say A is 8. B is 12. Then that's 64 plus 144. I'm not too concerned about just this kind of maths. You can do this in your calculator if you want. You can even do this whole thing in your calculator. But, okay, now we're up to C squared equals 208. We have a slight issue because we need to find C. We need to find a way of finding C. And the way to do that is to think about square roots. Now, square roots is just the opposite of squared. So if I have 3 squared, that's 9. 3 times 3. Square root starts off with a number and thinks, what number could I use and times by itself to get this number? And of course you know, because we just did it. The only number that I can times by itself to get 9 is 3. So we say the square root of 9 is 3. Now, that's the same as saying square root of 3 squared equals 3, isn't it? So you can see the square root, if I have a number like 3, and I have a square and a square root, they kind of cancel each other out, and I just have the number on its own. So what we can do is, we can do square root of this, and that'll cancel out the square, but because it's an equation, we need to do square root to the other side as well. So, finally, we're going to have a way of working out what C is, because a square root cancels out the square to just give us C, which is square root of 208. Last time I did this, my PowerPoint presentation disappeared. We'll see if it stays there. Okay, so square root of 208, I already did this and looked it up. It's 14.4. Oh good, it's still there. Alright. So, 14.4. And this was all in meters, wasn't it? So, 14.4 meters. Okay, so that's how to use Pythagoras' theorem. You start off by writing the equation, you substitute in the numbers, and by the way, sometimes you can sometimes you know what this one is, you just don't know what one of these ones are. So you can substitute in different numbers. In that case, you would leave A alone and you'd substitute in these two. All right, so let's do a trickier example. Now this is a two-stage problem, sorry. Now, let's say we've got this shape, this rectangular prism, and let's say this length is 5 centimeters. And let's say this one is 10 centimeters. And this one is 12 centimeters. All right. And what if we have to find the length HB? Now, you can see we've got a triangle here, right? We've got HB on one side, we've got HE, and we've got EB. And even though you have to really think about this, it's in 3 dimensions, this is still a right-angled triangle. Okay, so can we work this out? We've got, why don't I say that's C, and I say that's Y, and that's X. So we know that this squared is equal to this squared plus this squared. But we only know what Y is, we don't know what X is, and we don't know what C is. So we can't work this out yet. We've got C squared equals Y squared plus X squared. All right, so how do we do this? We have to know what, we know what Y is, that's 5. 5 squared plus, we need to know what X is before we can keep going. So to do that, you need to use another right-angled triangle, which is this one. You've got EA and AB, and you've got X. So let's call this one A, and we'll call this one B. Okay, so A squared plus B squared equals X squared. So let's do that over here. A squared plus B squared equals X squared. Oh, sorry. I'll try and write it the other way around just so that we're used to writing it that way around. So X squared equals, so we'll have the hypotenuse on the left equals A squared plus B squared. So what's A? A is the same as this one, which is 10 centimeters. What's B? B is the same as this one, which is 12 centimeters. So that's 100 plus 144. And so that means we have X squared equals 244. Now I hope you remembered how to get rid of this squared. You need a square root both sides. So that'll cancel out the squared so that we only have X left equals square root of 244. And I really hope this doesn't disappear. I don't know what my PowerPoint is doing, but we'll see. So this is telling us it's 15.6, roughly. Okay. 15.6 centimeters. And now we can finally work out what C is because we found out what X is and we can put that in here. So 5 squared plus 15.6 squared. It's 25 plus, I can't do 15.6 squared. We can use a regular calculator for this. (15.6) squared, 243.36. Should have really given ourselves a bit more room here. Alright, so that is 263, 268. 16.36. And so that's c squared. To find out what c is, you do square root of both sides. And so let's do that. We've got 16.23. So there it is. Let's just check to see if our answers make sense. X is the diagonal, so it should be longer than A and B. So X is 15.6, it is longer than 10 and longer than 12, that's good. C should be even longer because it's a diagonal of this triangle. And C is a little bit longer, so that's good. The answers actually make sense. So that's Pythagoras and a tricky 3D example as well. If you didn't understand the 3D example, just start with some 2D ones and you can move on to 3D later. And you'll probably be a bit better at it after that. After you try the 2D ones. See you later.